Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 4, looking at lessons 12 and 13, which is about sequences. And I'm going to be honest with you, there's a lot of information in these lessons, so we're just going to a lot of new vocabulary and things going on. So stick with me here. We've got some terms that we want to make sure that we understand what they're talking about. So the first, let's just talk about what a sequence is to begin with. And you have the definition there. It's a list of objects, usually numbers when we're talking about math context, uh, that are written in a significant order. So a sequence really kind of means order. So we have this list of objects that are in a certain order. When we talk about terms, when we're talking about a sequence, a term is going to be an element in our sequence. So if I have this sequence here, 1, 2, 3, 4, 5, each of those numbers would be considered a term in that sequence. This particular sequence is what we call a finite sequence. Finite means that it has um, a finite number of terms, an exact number of terms. So we would say this sequence has 5 terms. It's finite. It doesn't continue on after we get to 5. So finite means we know exactly how many terms are in it. An infinite sequence, think of the word infinite or infinity, that means it has infinitely many terms. So it continues on and on. You see we have the same beginning of the sequence here, but notice we have the 3 dots at the end. That's to say that it's going to continue going and it's going to follow this pattern. So if you look at that sequence, it's increasing by 1 each time. So they don't give us the next term after 5, but we can reason that it's going to be 6 and then 7 and so on. All right. Sequences can have an explicit formula. So that's another term that we want to understand. If we say it has an explicit formula, then that means it has a formula for the nth term of the sequence in terms of the index n. So let's talk about what that means. That means that I can create a formula that would allow me to find any term in the sequence. So if I know that I know the first 5 terms of a sequence, but I want to know what would the 18th term be. Well, if I have an explicit formula, then I can use that formula to find the 18th term in the sequence. And so with sequences, those formulas allow us to use the pattern to find a certain term in the sequence. And so that's what they're talking about with the nth term of the sequence. I can plug in a number for n. So if I wanted the 18th term, the nth term here, n is 18. And so I would use that to find what that term is in that sequence. All right, and so a couple of specific types of sequences that we'll talk about. We're going to focus on what's called an arithmetic sequence. And an arithmetic sequence is a sequence that has a common difference between the pairs of numbers. So if you think of the word difference, difference is, we use that in subtraction. So arithmetic sequence deals with addition, subtraction. The other one I'm not going to talk about as much here, but I do want to at least mention it, is called a geometric sequence. And a geometric sequence, the difference there, instead of a common difference, we say that it has a common ratio. And so if you think a ratio means more like division. So you're going to use multiplication or division to go from one term to the next in a geometric sequence. All right, but let's talk about an arithmetic sequence. So if I have this sequence that's given here, 3, 7, 11, 15. Well, if we notice here, we have a common difference between each term. Each time I go from one term to the next, it's increasing by 4, right? So our common difference would be 4. And so we use the letter D to represent that common difference. So we would say that D equals 4. Well, with an arithmetic sequence, if I know that common difference and I know the first term in the sequence, which in this case is 3, then I can use this formula to create the formula for that sequence so that I could find what the nth term would be in that sequence. And so here we have a sub n, that's the term I'm trying to find, is equal to a sub 1. That's the first term in the sequence. So the first term in our sequence here is 3, plus our common difference, which is 4 times n minus 1. And so what this allows me to do is now we've been given the first 4 terms in the sequence here. Well, what if I wanted to know the 10th term in the sequence? Well, now I can use this formula that we created. I'm going to use a different color here just to keep it separated a little bit. So let's say I want to find the 10th term. So I want to know what's a sub 10. Well, I'm going to plug in 10 for n, and now I can solve this equation to find what this value would be. So I would do my parentheses first, thinking of order of operations. 10 minus 1 is 9. Then I would do my multiplication. 4 times 9 is 36. And 36 plus 3 is 39. So just by using this formula for that arithmetic sequence, I can figure out that the 10th term here would be 39. Now, I could also, I know the sequence here. I could add 4 each time, and I would eventually get to that 10th term. But if I wanted to know the 100th term, it would take me a long time to write all of those out to get to that. So this, by using that pattern in the geometric sequence, we can use that to help us find the nth term. And so that's what that next definition talks about. The nth term says that it's a formula that allows you to calculate any term in a sequence for a given value of n. And so we used that formula for the arithmetic sequence there to find that nth term. The last topic that we're going to look at are recursive formulas. And recursive formulas are a little bit more difficult to work with than explicit formulas, excuse me, because you have to use, as it says there, you have to use one or more of the previous terms to be able to create the formula for the nth term of the sequence. So what we're going to do with a recursive formula, so I have my sequence listed here, and so I want to start by identifying what f of 1 is. What's our first term in the sequence, which here is -2. And then if you notice, each term in the sequence, we're adding 3 to that term. Excuse me. So we're going to create our recursive formula. F of n is going to be equal to f of n minus 1 plus the 3 that we're adding each time. And this will only work for n values that are greater than 1. So we know what f of 1 is. F of 2, if I plug it into my formula over here, well, f of 2 minus 1, so that would be f of 1, which is -2. If I take -2 plus 3, I get 1. I could do the same thing for f of 3. So that's going to be f of 3 minus 1, which is 2. F of 2 we said is 1. 1 plus 3 is 4, and so on. And so you can see, recursive formulas are not going to be as powerful for you in finding terms in a sequence as those explicit formulas that we saw earlier in our lesson here. All right, and that's all I've got for you guys today. Appreciate you taking the time to watch. As always, if you have questions, please let me know. Thanks. Have a great day.